Hey everybody, this is Larry. This is me going Q2 of the weekly contest 450 minimum swaps to sort by digit sum. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. This one I was just being silly. I end up doing it in 12 minutes and 12 minutes and with a 5-minute penalty just because I had a silly understanding. I mean the So also, I thought that initially it was going to be minimum swaps with swaps being adjacent swaps. So in that case, it is the number of inversions, which is also another well-known problem, but this is not that problem. But that said, for this one, all you have to do is simulate the swap with selection sort, kind of, if you know, because basically you know where it should begin, right, or where the input is, and you know where it should end up, right? And sorting, I kind of hand waved over it, but I made a copy of the way I sorted, right, by the digit sum, which we kind of went over in Q1, and then the tiebreaker being X, where X is the number, so that's the tiebreaker, right? So we sorted by that. We do the lookup, right, and it's just basically mapping where it should be from where it is, right? Yeah. And then for each one, you simulate the swap out. For example, and then for this particular problem, because they're unique, there's only one way to map each other, right? If you kind of want to, actually, let me draw it out real quick. Bring up the drawing board. Well, I think it's easy to mess up, and I messed up, right? So that's why maybe I'm putting a little bit more emphasis on it. But okay, so the idea here, and it kind of deals with permutation cycles and stuff like that, though you don't necessarily need to know that. But it's just that, yeah, and actually the number doesn't matter. So I'm just gonna make up random things, right? So let's just say you're starting from A, B, C, D, E or something, and then after you do the sorting function, and the sorting function is just by itself, right? So then now you know that maybe after sorting you have, like, A, D, B, E, right, something like that, and all you need to know is that you're trying to make these moves, right? And it doesn't really. So then now you just go one at a time, right? So then you want to get to this state, from this state going one at a time. So here you just go, okay, well, what goes into here, right? It's a C. So then now, because this is a C, or because this is currently A, well, there's really no let me re-say that. So because we want this to be a C, but it is currently an A, so then we just swap, right? We know where the C is, or we keep track of where the C is. So then now we swap the C with A. Why does this work? Well, because with a swap you can only, well, technically 3 things can happen, right? One is that both of those swaps mix it into like they're both in each other's places, so one swap fixes 2 places, right? And then in other cases, well, only one of them is swapped into place, so then you swap one of them. And then the other, of course, is that, I don't know, you're swapping random stuff that makes no sense, so we're gonna ignore that. But yeah, so that means that every time you do a swap, you at least improve your result by 1, right? And without going into the proof as to why this is optimal, is that I would recommend reading up on permutation cycles and stuff like that. You could kind of, so basically, if you have a permutation cycle of length n, you need n minus 1 swaps. That's basically the idea. And this is a different way of doing that permutation cycle implicitly, right? Maybe I should have done if I did it with permutation cycle. Maybe that would have been I wouldn't have made a silly mistake. But anyway, that's the idea. So maybe I could rename this a little bit. So maybe this is, I could rename this as source, right? There should be a refactoring code somewhere. And then maybe this is target, right? And yeah, let me run it real quick. Nope. Missed a spot somewhere. Okay, so maybe this is a little bit cleaner. Give it a submit just in case. Yeah. right? So then now we make a lookup table of the source so that in the source we know where it is, right? So then now we want to get to target. Yeah, we're trying to get to target. If the target is already there, then we don't need to do a swap, so then we just skip to the next one. Otherwise, and of course, because everything's unique, if it's already in the correct place, nothing can swap into it, right? So we're done. Otherwise, we look at where. So other is a weird name maybe, but it just means where in the source. Let me write this out. Other is where in the source is X currently, right? So we know that we want X to be an index in the final place because that's the target, right? But it is in the other index currently. So then basically we do a swap, and in doing the swap, we also have to update the lookup index. And that's basically it. And then we just count one of the swaps. And yeah, what's the complexity here? Well, we do a sorting, so that's going to be, excuse me, that's going to be n log n. Can't really dodge that. You can maybe say d sum takes all of d, where d is the number of digits or something like that for extra complexity. But then in theory, you can also say that about everything else. So yeah, that's it. That's all I have for this one. Dominated by the sort, but then it's just about this permutation cycle thing. And I just kind of, if you watch the live portion, what I made a mistake on is just I kind of swapped the wrong thing. I think that's the TLDR. I was just being lazy, to be frank. I probably could have checked this. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. And you can watch me solve it live during the video now. I was like, I don't get it because it just 2, 1, negative 1. Okay. Silly misreading maybe. But all right, let's go. Some of the digits seem pretty straightforward. So you sort by minimum number of swaps. That's awkward. I mean, it's an annoying problem. It's a merge sort problem. Classic merge sort. I mean, I thought it was just sorting, but yeah. What you could do with merge sort, you could do with just whatever, right? Let's see. Insertion, maybe? No. Yeah, okay, fine. Yeah, it's just annoying. Right? You just count the number of inversion. It's a very well-known problem in general. Wait, is this swaps as in adjacent swaps? What is a swap? Oh, actually, then I'm wrong maybe. Or at least not this way. I mean, I was like, because some of them is in adjacent swap, right? So then now it's insertion sort. Is it insertion sort or? Well, either insertion sort or selection sort, but either way they're n square, so that's going to be too slow, right? How do I do it then? Well, first we sort, right? I guess that's fine, that part. And the distinct. Okay, distinct makes it a little bit easier. I guess it's just permutation cycle thing. So I think it's just simulation, right? There's nothing to do about it. So you call digit sum and smaller number. Okay. So the sum x and then x, right? We already did this for part 1, but I guess this is easy enough to write. Though maybe I will write it incorrectly this time. Right? Oh, not this. I mean, this is fine, but maybe look up. Really, just the problem seems annoying. And then now for okay, so if index we continue, otherwise we have to swap, right? So we swap on the original, right? Now maybe I should have done it the other way. Actually, I think the other way makes more sense for the lookup. Okay, fine. Well, it makes it more intuitive, maybe. Okay, so then now if the result, okay, fine. Otherwise, then we have to swap them into where looks up 2 is, and we do a swap. Oops. Lookup of x, not index. Okay, but then now no, that's fine, I think. Maybe. Maybe. 102. I think this is fine. YOLO. Is it not greedy? Am I missing something? Okay, so okay, so you have this, right? And I'm saying that the answer is 2. Why do I think the answer is 2? Because, okay, first, oh, I'm doing it incorrectly. I did it in the wrong order. Okay, so because I swapped this into the third element instead of the other way around. I need, okay, I got it wrong. Okay, I see. What I need is having this. I need to, yeah, okay, so I did do it wrong. So I do need the nums instead of nums. Yeah, okay. Yeah, maybe I should have printed it. Still wrong. Nums 2 is sorted. Let's double check that it's sorted afterwards. This is not sorted afterwards, so that's not right. nums2 is already sorted, right? What am I doing? Okay, slow down. Okay, so we have to look up. This is where we want to. Is that where we want to be? No, that's the original index, and then the sorted order. Oh, well, this is also wrong, even if we wanted to sort it into this. Oh, no, this is the sorted order, I think. Nope. And I'm just being dumb today. Okay, so this is the order, the correct order. We have the lookup table looking like. No, what we want is, okay, I know what I'm doing, but kind of. Apparently not though. Okay, what we want is we want this. So we want to know the index of here. So it's not that we, okay, I think my first idea was more right, but I did it in a dumb way. Okay. So it's not that I want, it's a struggle. I mean, I get it. It's just, okay. But why am I not putting anything? Okay, so I want to get from here to here. So then, but then I iterate on this one now. So I need to iterate on this one. So nums2, with the lookup being on the index, right? Because we want this to be the answer. So then now we go, okay, well, where is this? So then we swap it. Okay, that's just very wrong as well. 204. Or maybe not wrong, but we have to update the index. So then now lookup of x is equal to index. And then what's the previous number? So the nums of lookup of x. Okay, let's just do, okay. Other index is equal to lookup of x, right? Then we swap them. Lookup of, so then now lookup of x is equal to other. And then lookup of nums of other is equal to other. Okay, x, lookup of x is already indexed. Oh no, we want to make that, so that's true. Lookup of the other is the other, right? Maybe. Okay, 1023. I think this is more right. I just kind of really bad at mathing. It might still be wrong, honestly. Okay. Dumb, silly Larry. Okay. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, explanation, everything in between. Stay good, stay healthy, to mental health. I'll see y'all later and take care. Bye-bye.